Okay, we're in Advanced Math Trig, Mod 7, continuing our chapter on exponential functions, exponential equations, logarithms, and in this case today, logarithmic equations. Once again, we're going to be solving equations that are found on a worksheet that's also attached to your Schoology. Today, guys, it is Friday. So Friday, 4/24/20, April 24th. Friday, April 24th, top left corner of your paper. The title says Logarithmic Equations. Now the equations we're going to solve all have the word log somewhere in them. It could be an ln, natural log. Could be log, a common log. Heck, it could say log base 7 or log base 8. So any equation that you're solving that has the word log already in it, of course, is called a logarithmic equation. Well, like I said, there is a worksheet attached to Schoology as well. It'll say 424-427 worksheet. There are 20 questions instead of 32 on this one. So basically today on Friday, for our notes, I'm going to do numbers 1, 3, 5, and 7, and number 9 for you, okay? Teach you how to solve a logarithmic equation. It's different than what we've done the last 2 days, so stay with me, pay attention, and think right along with me. Don't just copy. And since I'm doing 1 through 9 odd, your homework assignment to see if you understand this will be 2 to 10 even, okay? All right, here we go. Start on the front of your paper. Again, the title is Logarithmic Equations. Problem number 1. Now, it's your call. If you want to print out the worksheet that's attached on Schoology along with this day of notes, all 20 questions are already listed and written out there. Mr. DeMarco had that ready to go with all 20 problems. And you could kind of look ahead of time what these are, or just stay with me now. I've copied them onto my paper, and we'll do them from here, okay? All right, this says ln x equals 5. Now, guys, shift gears mentally a little bit. The last 2 days when you've solved exponential equations, it has always been the expression what? When in doubt, log it out, because you had a base raised to a missing exponent equaled some number, and we had to log both sides to try to isolate the exponent that we were seeking. Well, if you look at this problem, obviously we're not going to log both sides when the word log is already there. Oh, so if I have an equation and it already has the word log in it, in this case ln, which is a natural log, we're going to go back to our old buddy Ben that we learned a few days ago. Remember, every time you see the word log, you were trained, think Ben, which stands for what again? Base, exponent, number. Base raised to an exponent, giving me a final number. Look at this problem. Obviously, if it's an ln, a natural log, remember your base down here is understood to be an e, isn't it? So if I use Ben on this equation, my base is e. My exponent is always on the other side of the equal sign, which is a 5, right? Equals, and then my final number is back over on the left side, which is x. Oh, so every time I have a log equation that already has one word log in it, okay, now careful, when there's 2 words that say log, then we're in trouble. But for right now, if there's 1 log, you think Ben. You take your, follow the bouncing pen, base, exponent, final number. So I've got e to the 5th equals x. Now, good news is, like any other equation, of course, we're trying to solve for x. Well, it's already by itself. So all you've got to do is go to your calculator and hit e to the 5th power and see what that equals. Now, guys, when you go to your calculator, there is an e button, okay? On my calculator, the E button is right above that little divided by. So you got to hit second divided by, and E pops up on your screen. And I want to raise that E to the, what, 5th power, giving me 148.413. Again, round it off to the nearest three places. Any exponential or logarithmic situation. Okay, pretty easy first question. Okay, we're doing 1, 3, 5, 7, 9. So let's get rolling here. Number 3. It says the ln of 2x equals 2.4. At first glance, you're thinking, oh my gosh, how am I supposed to solve that equation? Your job is to get that x by itself, but this equation in which you're trying to isolate x has a logarithm in it, doesn't it? Every time you see a log, you think Ben. My base, again, is understood to be e. I'm raising it to the 2.4 power, right? That's my exponent, 2.4, equals, and what's back over on that side? 2x. Oh, so if my goal is to isolate x and get it by itself, of course I would divide by 2. And it looks like the missing x. Now, just like my advice the last 2 days, instead of typing all that in at one time, I'm going to do the top only first. I'm going to hit E raised to the 2.4. I'm going to hit enter, then push divided by 2 instead of all at one time. And I've got a missing x of 5.515. So that's really 5.512. Agreed? 5.512 to the nearest three places. Okay? Number 5. Third one we're doing together here. Number 5, it says 2 log 4x equals 0. Okay, now careful, guys. Don't bend that yet. All right? Don't take your base and raise it to that exponent yet. Oh, because there's a dot connected number in front. Guys, don't think Ben until it just has a log by itself. Just has a log by itself. This log that we're about to do has a 2 in front of it. I don't want that 2 to be there. So I'm going to divide both sides by 2. He cancels out. Now, kind of good news on this one. It doesn't change the right side, does it? Because when I take 0 and divide it by 2, I still get 0. Now that I just have the word log here, I can use the word Ben, right? Every time you see log, you use Ben. Now, careful, what's my base this time? Remember, on a common logarithm, we discussed this a couple days ago when we expanded and condensed things. If you ever see the word log and you don't see a base, it's understood to be a 10, isn't it? Not e, because it doesn't say ln. This is not a natural log. It's log. So my base is understood to be 10. My exponent is 0 equals what number? 4x. Okay, I'm not even going to need a calculator. Now, careful, if you're not thinking, some of you will see 10 to the 0 and you'll write 0. That's wrong. Anything to the 0 power gives you 1. Agreed? Equals 4x. Obviously, I divide by 4. And x equals 1/4, which, of course, is a decimal. If we want to make it a decimal, 0.25. Okay? And then number 7, which is the last one on the front of my paper. Oh boy, there's a radical. Okay, always slow the game down and think. The bad news is, yes, there's a radical, but the good news is there's only one ln here. I've got the ln of radical x plus 2. Every time I see a logarithm, I think Ben. So my base is understood to be an e. My exponent, right, base exponent number, we're always going in that order, that pattern. My base is e, my exponent is 1. So I got e to the first power. I don't even need to write a 1, do I? There's no point to writing e to the first power, so it's just e. Equals, and then that side I've got radical x plus 2. Now, guys, there's no more ln's. There's no more logarithms. E is just some number, isn't it? What is it, 2.718? So instead of getting stuck now and saying, oh my gosh, what do I do? Remember, your goal is to get this x by itself. The opposite of square root box is to square both sides, agreed? So I've got e squared equals, and when you take a radical box and square it, remember that just makes it disappear, giving me x plus 2. So to get that x all by itself, I subtract over my 2, and x equals, and then you're going to go to your calculator. I'm hitting e to the second power, hitting enter, and then minus 2, enter, and it looks like we get 5.389 to the nearest three places again. Okay, so I've done 1, 3, 5, 7, number 9, the grand finale for today. Uh-oh, careful. Obviously, if I said play detective and asked what's different about this one than the 3 or 4 that we just did, there's 2 logs to begin with. Oh boy. So guys, we're not going to use Ben yet. You can only use base, exponent, final number when there's just 1 log sitting there. This is 2 logs connected by a plus sign. Something should look familiar. Something should be kind of jumping into your brain right now. Remember a couple of days ago, 3 days ago, we had a homework about expanding and condensing logarithms. What was the rule when that was a plus sign in the middle? Remember the rule, the product rule said the log of m times n equaled the log of m plus the log of n. I've got the log of m plus the log of n here. Anytime we had the log of m times n and it was a times sign, it turned into a plus sign. So if we're going to condense this, like we did 3 days ago, oh, if I have the log of x plus the log of x minus 2 and there's a plus in the middle, wouldn't you condense this into the ln of x times x minus 2 equals 1, right? Remember, the log of something times something got split up into the log of the first thing plus the log of the second thing. So condensing that, that's why we practice that, we end up with this right here. And now there's only 1 logarithm in the problem. So I can use Ben, right? My base is understood to be e, base, exponent, final number. Follow the pen again. I have a base, an exponent, and a final number. So e to the first, again, I don't need to write a 1 up there, equals, now, that says x times x minus 2. That's actually what? X squared minus 2x. Agreed? If I distribute the x. Uh-oh. Now what do we do? Guys, careful. This is a quadratic equation, isn't it? It's got an x squared in it. E is simply some number. Wasn't the rule when you ever solved quadratic equations to just get everything over on one side so it's equal to 0 and it was in quote standard form? So if I take that e and subtract it over to the other side, I've got 0 equals x squared minus 2x minus e. Oh, and that's now a trinomial, isn't it? It's a quadratic equation. I got everything on one side. It's equal to 0. It's in standard form. Normally at this point, your instinct is to try and what? Factor that. Now, guys, there's no point to trying that, right? You agree if that's x squared, we'd have x and x. I have a minus, so the signs are different. There's no way we can use e and 1 and have it equal to middle number 2. So factoring is not an option. Unfortunately, our only choice is to use good old what? Negative b plus or minus square root b squared minus 4ac all over 2a, the quadratic formula. Okay? If you've got a graphing calculator that's advanced enough, like one of those TI-89s, I believe there's a quadratic formula button in there where you can type in your A and your B and your C and have it do the work for you. A is 1, right? That's the number out in front. B is negative 2, and C is negative e. I'm going to take A, B, C and plug them in. to our famous quadratic formula to solve this quadratic equation. So here we go. Stay with me. Opposite of b. The opposite of negative 2 is 2 plus or minus square root b squared. Well, I take negative 2 and I square it, and I get positive 4 minus 4 times, now a is what? 1 times c, which is negative e, all over 2a. So that's just going to be 2, because it's going to be 2 times what? 1. I'm just using the quadratic formula. Now careful, guys. When you clean this up, obviously I have negative 4 times 1 times negative e, and a negative times a negative is a positive. So really it ends up being what inside here? 2 plus or minus the square root of 4 plus 4e all over 2. So my answers are, okay, now don't panic here. Take your calculator. Now I'm going to look inside here. I'm going to take 4 times e. So 4 times e. Hit enter. And then plus 4. Hit enter. Now I'm getting 14.87 on my calculator underneath the root box, and that's now got to get square rooted, doesn't it? So I'm going to square root that answer and get 3.857. So I got 2 plus or minus 3.857 all over 2, finally giving me, now obviously what's 2 plus 3.857, that'd be 5.857. So I'm pushing 5.857 divided by 2, getting 2.929. And then, okay, now be careful here, 2 minus 3.857 is going to give me a negative number divided by 2, giving me a negative answer of some kind. Now, why am I not even doing that on my calculator? Guys, if you get a negative answer, look at the original problem. If I took a negative number and plugged it in for x to check my answer, you can never have the log of a negative number, can you? Because remember, you can't take e and raise it to some exponent and have it turn out to be a negative number. It's impossible. So the negative answer, no matter what it is not going to work. So there's no point figuring it out exactly what it is. I ignore my negative answer and keep one answer, believe it or not, wow, of 2.929. Okay? Now, your homework, again, go to the worksheet that's on Schoology. It's found right underneath this video you just watched. And there's 20 problems on there. You're going to do 2 to 10 even. Okay, that's only 5 questions. Since today is Friday the 24th, those 5 questions, 2 to 10 even, are going to be due on Monday, the 27th by noon. When we come back on Monday, I'm going to go ahead and do 11 to 19 odd. They do get harder and more difficult in terms of how to manage the steps ahead of time. And of course, at that point, your homework will be 12 to 20 even, and we'll have that worksheet finished up, okay? So I would print that worksheet out so you've got it available. At least call it up on your screen, hit pause, and copy down 2 to 10 even, okay? Great job. Have a great weekend. See you on Monday.